Good morning and welcome to Pre-Calculus. This is Chapter 2.1. We are talking about quadratic functions and models today. I'm just going to remind you, if I am going too quickly and you need more time to write something down, remember that you can push pause, write it down, and then let it go again. Also back up if you need to see something more. And then keep in mind you can go to Chapter 2, Section 1 in our books, and you'll see a majority of these examples or something very similar in there so that you can look at those as well. But our goals of today's lesson are to basically review the quadratic functions. I know we've been working on those all year so far. We reviewed transformations and everything else like that, so it shouldn't be new, but that is the topic of this lesson. We're going to analyze graphs of quadratic functions. We're going to write quadratic functions in standard form, and we're going to sketch our graphs in standard form. If we get time, we're also going to go into some real-life examples because you will have to do some of those for homework. So moving on. We talked about function families in the last chapter. We reviewed many of them. The functions we're going to be working with were all considered polynomial functions. And to clarify what that is, definition of a polynomial function. And this just says let n be a non-negative integer and let a sub n, and then the next term in the sequence, a sub n minus 1, on and on and on until we get to a2, a1, a sub 0. They're all going to be real numbers such that the largest one doesn't equal 0. And the functions are going to be given by this form right in there. It's called a polynomial with degree n. All right, plain and simple English. This is just saying that if we see some function that goes along here, the leading polynomial there, the one with the maximum power, and this is called a leading coefficient. That leading coefficient just can't be 0. That's how we're going to define our polynomial. So if I had 7x to the third minus 2x plus 3, something along those lines, my degree of this polynomial would be 3 because that is the largest exponent involved. The leading coefficient is 7. Notice it was okay to have 0 as a coefficient for the x squared term in that one. That's fine. It just says the leading coefficient can't be 0. And so that's how we're going to determine the degree. Today we're only going to work with something of degree 2, so we are dealing with quadratic functions in there. So quadratic equations. And the basic forms that we've talked about, they're considered standard forms. So all the way through Algebra 2, through last year for you all, this was our standard form. F of x equals ax squared plus bx plus c. That is what we had been using. Now that we have switched textbooks, we've switched authors, we are now more advanced. Our standard form is going to be the vertex form that we talked about last year. So we're going to be looking at f of x equals a times x minus h squared plus k. Just quick reminder for you, a is the same in both. We're going to review what that does here shortly in the lesson. And then we also, you may recall that this is your vertex. So we've got h, k, that is the vertex. Here we have to do more work in order to find our vertex up on the top one. You are not sitting in the classroom, so you can't see where I'm pointing. That will be the new thing for presenting like this. All right, so what I wanted to do is I pulled up Desmos here so we could do this a little bit faster for you. And notice I just turned on the y equals x squared. So that is the one that is currently graphed right there. And I could have done a table of values to get it. That's our parent function. It is quadratic. Leading coefficient is 1, so a is 1. Vertex is at 0, 0. So now I'm going to turn on this next one. And last week we talked a lot about, okay, so how is this going to move? What is the transformation involved going to look like? So if you see that minus 2 in parentheses with the x, hopefully in your mind you're thinking, okay, what's that going to do to this function? And then the plus 3 tagged on the end. That should move it right 2 and up 3. So notice the vertex has, we aren't changing the size yet. We haven't shifted with that at all, but we just went right 2, up 3. Next one, All right, that's not in standard form. It's rearranged. But we could, it's going to graph right like this on decimals, but I could think of it as y equals opposite of x plus 6 squared plus 5. Great. All right, if I keep my standard way of thinking with it, this plus 6, that's going to move it left 6. And then this minus sign out in the front, well, that should reflect it over the x-axis, if you recall correctly. And then the plus 5 should move it up 5. So let's just see what that does. I'm going to turn off the earlier one, and we'll turn this one on. And yep, it did reflect it, so it went upside down. And then it moved it left 6, up 5. So that worked. This one now, this is in standard form. My vertex is at x plus 0 squared plus 2. So it is flipped so it opens down. My vertex is going to be at 0, 2. So it's going to shift up 2, left, right, none. So if I turn this one off and go with that, there we go with that one. So hopefully now this one, open up or down, think about it. And then how's it shifted? So hopefully you said it opens down, shift left, up 3. So if I do that, here we go, let's check it and see what happens here. Yep, left 1, up 3. Very good. I'm going to actually get rid of these so that they are not there, and I'm going to clear that ink. So that is not there as well. All right, this one can go away. Now we're going to make a little switch. What happened when we changed A? Narrow or wider? What's going to happen? And if you recall correctly, it's fractional in value, which means it's going to stretch things out. It takes every single x value gets cut in half. So in order to reach the same y height, it's going to take twice as long. So this should get wider. And then the negative made it go upside down. The 4x squared should get narrower. And so you can see it is narrower in there. So we do have those in there. This is just a fun little standard operator that we've got here. Let me, I got to undo. I deleted the wrong one there. This has sliders automatically built in there. And so if I just want to know, all right, what is going to happen if I change that A? And you can see, if it's fractional values, it stretches it out, makes it wider. If it's 0, we don't have a leading coefficient at all. That's what we talked about earlier. And then the larger the number, the narrower it gets. This is a fun thing to play with. You can just see your transformations moving. Feel free to do something like that on decimals. We're going to pause here and we're going to pick up the second part of the lesson momentarily.